Are you ready?
Give me something new. I want it back.
We're going to be exploring the chemical potential energy that's in baking soda and vinegar. Now, when you mix these two, there's a chemical reaction, and you wouldn't even realize that there's stored or potential energy in the molecular bonds of these two substances unless you mix them. Now, just like wood with a fire, you wouldn't realize there's potential energy in that wood until you see the reaction. Now, when we mix a vinegar and baking soda, it's a 12-to-1 ratio, meaning that there's going to be 12 parts of vinegar and 1 part of baking soda. So you are going to need 1 tablespoon of baking soda and 12 tablespoons of white vinegar. Now, 12 tablespoons of vinegar is equal to 3/4 of a cup. You're going to need 1/4 measuring cup of a tablespoon, a cup, and either a balloon or a glove. For this experiment, you need a balloon and a funnel. Now, I don't have a funnel, so I took the inside of a tape dispenser because I need something to put the balloon around so that I can easily put a substance inside of it. So, it's a little bit of a struggle. Okay, you'll also need a container that you can fit the balloon's edges around. And a water bottle might be the best solution for you. If you have a smaller balloon, you can use a teaspoon and a 1/4 cup, and that's equal to 12 teaspoons of vinegar and 1 teaspoon of baking soda. Now, inside of these two substances, potential chemical energy is stored. And we are going to release that with a chemical reaction. And the chemical reaction will turn some of the particles into air particles. Now, air particles spread out, so they have no set shape. That's why we have to contain them with the balloon. Obviously, a solid has a set shape, and a liquid takes the shape of whatever container is around it. So that's why we have to have this balloon as a container. I'm going to go ahead and pour my vinegar into my bottle. Ooh, it's been getting messy all day here. And I have another vinegar gallon here. Never know when you need this stuff around. It's good for cleaning, cooking, science experiments. I'm putting a little extra because I think my first one was a little shy. Now, make sure you don't have a little water balloon. That might explode rather quickly, and you might even want to go outside. I'm sure some of your parents would appreciate that. Now, I'm going to go ahead and put my balloon over the top without spilling the baking soda inside, because if I do that, then I'll get my reaction before I'm ever able to get the balloon on. Now let's see how far this balloon blows up. Are you ready? Now I'm going to watch this chemical reaction work. That was an interesting balloon. It looks like a fish. And it's blowing up the balloon because that energy has been released from the molecular bond. And that's science. Hopefully you have a glove. It's a little easier to get the baking soda into the glove than the balloon. If you have a balloon, I would use a funnel. Now, I'm going to put this around the rim, but the baking soda is still in the fingers of the glove. Okay, I think we're ready. This chemical reaction is turning the particles into air. And
Ms. Lopez?
Oh no!
as you can see, there's a huge reaction. Now I think I needed to get my seal more around there because this glove would have stayed on. Oh, you can see how the energy itself is moving the glove. And there you go.